Okay, number 61, we're given the voltage of a battery. We're also given the current, if you look down there at the diagram. And the question is asking, what is the power? Well, let's think about our equation for power. We know that P is equal to I times V. So let's just plug in our numbers here. And we can get the power. Remember, this is joules per second. So, again, power is measured in watts, which is equal to joules per second. So for part B, it's asking how much energy is converted in 15 minutes? Well, there's 18 joules in 1 second. So how many joules are there in 18 minutes? Well, we got to do a little conversion here. Let's convert joules per second to joules per minute by doing from seconds to minutes there, and then we can multiply by 15 minutes to get your answer. So ultimately, you're doing 18 times 60 times 15 to get however many joules there are in 15 minutes. In 62, we're given a circuit diagram. So this is something we haven't really done a lot of these problems in class, so I hope that this clarifies it for you. The first question is, what is the ammeter reading? So remember, the ammeter is just the thing that measures the amps, which is the current. So this is the ammeter right over here. And what is the ammeter reading? Well, what do we know about the circuit at that point in time? We know it's receiving 27 volts, and we know that the resistance is 18 ohms. So, knowing the voltage and the resistance, we can find the current. That's what an ammeter reads. So remember, the current is abbreviated with the letter I, and the units are measured in amps.
Mr. Kukulia, please contact 1402 9th grade office. Thank you.
Okay, so we're trying to find current, which is abbreviated with the letter I, and it's measured in amps. Okay, so let's think about this. We know that V is equal to IR. This is one of these big equations that we keep on using different versions of. I don't want to let you get confused. This is the one that I like to memorize. That's just the one that I learned in high school. The one that I gave you is R is equal to V divided by I. Same exact thing. And the only one that we're missing here is where you solve for I, and that would be V divided by R. So these are all the same exact equation, just solved for each of the three variables. So the most useful one for this question would be this one, because we want to know what I is. I is equal to V divided by R. So let's just solve that real quick. V is 27. R is 18. So you do 27 divided by 18, which would be 3 over 2, or 1 2/3. I'm sorry, not 1 2/3, 1.5. So I is equal to 1.5 amps. 1.5 amps. Okay, I'm going to use my eraser here and sort of clean this up a little bit. I'm just going to write 1.5 amps up at the top here. Oops. We have 1.5 amps. Okay, cool. Part 2, what should the voltmeter reading be? What should the voltmeter reading be? Wait a minute, I thought I already knew the volts. I thought the volts were 27. Well, you started with 27 at the top of the waterfall, but when you're halfway through the current, halfway through the circuit, then the voltage can change. I'm going to draw out the diagram that I drew in class again. It's just like starting from the top of a waterfall. That's the best way to think of a circuit. And you can fall down every time you have a resistor, and then eventually you have no voltage. But then what a battery does is it just takes you back around and brings you back up to the top of the waterfall again. So essentially what a battery is doing is it's letting water flow, letting electrons flow down the waterfall, and then once the electrons get to the bottom of the waterfall, they get pumped back to the top again by the battery. That's what a battery does. It just pumps electrons back to the top again so that they can fall down. And every time you fall down here, and then you fall down here, and then you fall down here. Every time you fall down, that's a resistor, and that's when you're doing work. You're either lighting a light, or turning on a radio, or whatever you're going to do. So, anyway, where were we? We are trying to find the voltage at that particular spot. So for example, take a look at the waterfall I drew. Maybe right here is what we're trying to solve for. We started at 27, but we're not at 27 anymore because we've hit a resistor. And then here's another resistor here, and here's another resistor here. Every time you hit a resistor, you drop voltage. It's like water falling down a stream. So what is the voltage right here at this moment in time? We started with 27, but it's not 27 anymore. And the way we can use it is we can use our resistance, which we know is 18. We know our current here. Excuse me, we don't know the current. Yes, we do. We know the current there, which is 1.5. So what we do when we want to find the voltage is we multiply the current times the resistance, V equals IR, and you solve. So it would be 1.5 times 18, which, as it happens, is 27 volts. So in this case, it's the same as what we started with. But you need to use this method every single time. You need to actually go through the motions and solve the problem. In this particular example, the voltage is the same exact amount that we started with. But that's because this is a very simple circuit diagram. So I want to get you in the habit of calculating it separately every single time. Let me erase this and make some more room. We have, let's see, what's the next part? The next question is asking, how much power is delivered to the resistor? Well, we know that power is equal to I times V, so that would be 1.5 times 27. Let's see, 40.5 is what I got. 41, yep, okay, so let's call that 41 watts. And the next part, D, how much energy is delivered to the resistor in 1 hour? Remember, watts are joules per second. So if you want to know joules per hour, you have to multiply by 3,600 because there are 3,600 seconds in an hour. So if you do 41 times 3,600, you will get your answer. Okay. 63, we have a very similar drawing here, a little bit different numbers. What should the ammeter reading be? Ammeter right here is going to measure your amps. It's going to measure your current. What is the current there? Well, we know that the voltage is 27, and we know that the resistance is 9. The equation that I always remember is V equals IR. So you can rearrange that. You can solve for I. I equals V divided by R, which is going to be, the voltage is 27, the resistance is 9. 27 divided by 9 equals 3. So you have 3 amps for your current. Part B, what should the voltmeter reading be? What is the voltage measuring right there? As I mentioned in the last problem, you really got to get in the habit of doing this the long way. You got to actually think about your equation for voltage. V equals IR. Your current is, we just figured it out, it's 3. Your resistance is right there, that's 9. 3 times 9 is 27. So we have the same voltage that we started with. And I can't express enough that this is not always going to be the case. Once we get more complicated, there's going to be different voltage, but you got to get in the habit of doing it the long way. Part C, how much power is delivered? We know that power is equal to current times voltage, which would be, where's the current? 3.
Mr. Glapion, can you come to the front office? Mr. Glapion, to the front office.
It's 81 watts. And for part D, how much energy is delivered to the resistor per hour? Watts is, let me try to make more room here. Let me write it over here. You know that watts is joules per second. So if I want to know how much energy is delivered in 1 hour, you have to multiply your watts by 3,600 because there are 3,600 seconds in 1 hour. Okay, 64 here, we have another one. First question, the same thing. What is the ammeter going to read? There's your ammeter right there. Your ammeter measures the current. I don't know what the current is, but I know the voltage is 9-volt battery, just like the square kind that you get at the store. The resistance is 18 ohms. I always remember V equals IR. That's my favorite one to remember. I is equal to V divided by R. That's the one that we're going to use. So I is equal to 9 divided by 18, which is 0.5 amps. Okay. Voltage is equal to current times resistance. The current is 0.5. We just figured that out. The resistance is 18. 0.5 times 18 is 9 volts. So it just so happens that it's the same voltage that we started out with, because this is an easy circuit. Next part is the power. I'm going to write it over here. Power is equal to I times V, which in this case would be 0.5 times, where's the voltage? 9. So that would be 4.5 watts. Okay. And then finally, how much energy is delivered in 1 hour? Remember that the watts tells you joules per second. So if you want to find joules per hour, you got to multiply by 3600 because there are 3600 seconds in an hour. 65. Sorry, I forgot to. Here we go. We're given the current and we are given the voltage of a toaster. The question is, what is the power? We know our equation for power is simply the current times the voltage. So you just got to plug it in. We're given the current, we're given the voltage. You got to find the power again. Here we are given the current, we are given the voltage. We got to figure out how much power it is. I hope that you are getting familiar with this equation by now. I'm not going to solve it for you. You can figure that out. It's in watts. Remember, watts are joules per second. So for part B, when the question says how much energy is converted in 5 minutes, you have to convert joules per second into joules per 5 minutes. So for those of you who are unit conversionally challenged, you have joules per second, and you want to convert it into minutes, right? What's it say? 5 minutes. So how many seconds are in 5 minutes? Well, 60 times 5. That's how many? 300. So there are 300 seconds in 5 minutes. So the seconds cancel out. You multiply, and then you'll get your answer in terms of 5 minutes. That's how you do it. 68, we're given the voltage. We are given the current. The question is, how many joules of energy does it use per second? Well, guess what? That's the same as a watt. Joules per second and watts are the same thing. So if you can find the power, that is the answer to part A and to part B, because joules per second and watts are exactly the same thing. I hope that this was helpful.